Hello and good afternoon. I'd like to welcome everybody who has joined us for this short webinar this afternoon. As a brief introduction to the SysMIC course that you have signed up to and that you are going to work through, and I'm sure very successfully over the next weeks and months. So the plan for today was to give you a brief background beforehand by the director of the course, and I will then show you the contents of the course and explain a little bit of what we expect you to do and how you can work and how you can then successfully manage to go through the course. And we will end with offering all sorts of possibilities for you to get help from us. And that will conclude the course for today. And the first thing, I would like to introduce the SysMIC team. So we have an administrator, that is Hannah Lawrence, and you should be in contact with her already. And we have Phil Lewis, who is helping on the course materials and the technical part of the course. And welcome next to me, Geraint Thomas. Come join in, Geraint, who's the director of the course, and who will start by giving you an overview of what this all is about and why it is important.
Okay, well, thank you, Gerald. I just want to say a few words, and I'll be necessarily brief. So it's a great pleasure to be involved once again in the running of this excellent course. SysMIC is now a very well-established program. It's built on excellent and highly refined materials that have been tried out now by over 2,000 students who've enrolled in the program and who are now actively using skills and knowledge and approaches gained in the program, either in their research or elsewhere in their lives. So there's no doubt that bioscience has become, in the last 10, 15, 20 years, much more quantitative than it was in generations before that. There are two problems really that have arisen that are driving this. First of all, data is becoming cheaper and cheaper to acquire in almost every walk of life, and that includes research biosciences and pretty much touches every facet of our lives at the moment, as well as our research lives. There's also the problem that biology and biosciences is inherently complex on any single scale of life or across scales. It's just one of the features that differentiates life sciences from physical sciences, where there the problems are problems of scale. And in order to cope with this avalanche of data or to cope with this complexity, it's true to say there's only one system of working and writing and thinking or approach that is sufficiently compact and clear to allow unambiguous or less ambiguous communications between research professionals, and that is the languages of mathematics and the languages of computation and the interaction between the two. This will also be, for many of you who've not had a particularly quantitative approach to your science so far, an opportunity to begin to probe the sort of interdisciplinary nature of the way that research is often done. You know, essentially a journey in how to see your research questions and problems through the eyes of other types of investigators. You know, when looking at a biological problem that you may appreciate in the lab or in the field, you know, how is that viewed from by somebody who isn't necessarily an experimentalist, but is highly quantitative and highly computational in their approach? Because in that journey lies the opportunity to encounter the power of and the professional power of a courteous way of working, a willingness to engage with the hard thinking and hard doing of other disciplines, to try to meet scientists from other starting points midway, or at least some way towards a collaborative interaction where both sides are contributing instead of one side just handing on the problem to another. As bioscientists in a data science rich and mathematical environment, I think it's important for the biologists to maintain a grip of the problem and not to let it slip away in order that the research remains attached to biological reality. But there is no doubt that the big biosciences problems of the future, well, currently now and of the future, are being tackled by larger and larger teams, of which only some members will be people who we conventionally call biologists. And this is the way of approaching some of the very toughest problems that are being asked at the moment. So having set that scene and said a little, I think, about the ethos behind the course, either explicitly or implicitly, I'll now hand back to Gerald and he can get you underway. Thank you very much.
Thank you, Geraint. I think that was a bit of a motivation behind it, and maybe you understand how it came about. And if I now go into the practicalities of the course, first thing I can do, I think, is I can try to share my screen with you, such that you have an opportunity to have a look at what's there waiting for you. Okay, this is our main website now that should show on your screen. And it basically gives you a bit of background information. But once you are enrolled in the course, you, of course, log in. And this is the landing site where you will start and where everything is waiting and ready there for you to be used. So you have signed up to Module 1. Maybe you saw from our website or somehow that we have 3 modules actually, where Module 2 is an advanced module and Module 3 is just project work. So all of you who are here now signed into Module 1, and here's what you get. We have it organized in 3 broad themes, and we start by looking at those themes. The first is networks. It's an introduction to programming, and it uses the MATLAB language, and it helps you to understand network biology. Second part, then if we scroll a little bit down, we do dynamical systems and modeling, where not only you're not looking at data specifically, but you're trying to come up with algorithms to explain the data. So there will be a major part where at the core you want to learn that writing algorithms, writing code is not just a way of doing some funny calculations, but it's a way of implementing biological thought in a communicable and machine readable way. After that, you have a choice. We offer you further languages. So if you are familiar with MATLAB, you can either do statistics with a language called R, or you can opt for bioinformatics in a language called Python. So we give you the options, and they are about equal weight, so it doesn't matter which one you do. But of course, having signed up to the course, all the material will be available to you. So by all means, go ahead and have a look at it and decide later on which one you want to do. If you have worked through the things that are necessary or that we tell you to do, then at the end of the course, you do a final project, which is at the bottom of the page now, called the mini project. And by handing in a mini project, which we have tutors to look at, give you feedback, and get it into a proper form, we will then be able to certify that you have successfully completed the course. So that's roughly it. You can see each of the sections is divided into sessions, and the sessions are numbered, so you go through them successively. Well, of course, nothing hinders you to jump forward and backward because it's all online materials. Everything is online, so there's no need to do anything else like going to classes or attending webinars, and I'll have a comment on webinars at the end of this session again. So everything is there for you. If you now get to this and you want to know what is actually waiting for you and how you're going to work through it, we might just have a look at one of the sessions. I just randomly pick one. Here's the network session. So if you click on one of these session links, then you get into a page that next to the navigation on the left-hand side allows you to see the contents, and that you need to read before you do it because it tells you what to do. It also tells you then what is the assignment. At the bottom tells you which assignment you are expected to do in order to advance and how to do it. And you can download the assignment file, because that's a file that you're going to use and that you can then finish. So everything is there waiting for you. So you have access to the materials. There's a webbook, a PDF version of it. You have certain files that you can download. You just saw me click on it. We should download them automatically. There's links to quizzes that help you work through and self-assess what you have done, so you can get a feel of whether you are actually up to the material, or maybe there's a little bit that you might want to look up again. So that's what it is. So let's just have a look at the inside of what it is when you click on the textbook and the material that you're supposed to work through. So the contents are organized in a nicely easy to navigate way. The navigation bar on the left, and on the right hand side the contents, and the contents consists of instructions. So there's some, say in this case about biological networks, there's a biological example which is exposed, and you're being told what the computational problems associated with these examples are. If you move a little bit further down, there's then code, where it shows you how to do code in the gray boxes. And this code is something that you're supposed to then either copy or type into your computer, into MATLAB, and execute and get the result. So in this case, for example, it's plot a histogram. Having done this, you understand what the problem is, how you respond with code to it, how you get a meaningful plot up, are exercises. Now you understand it, now you apply it, now you do what you actually supposed to do in your own work, namely now get a meaningful graph out of the data that you are interested in. And because you're not always sure whether what you do is right or wrong, we provide a solution. It's not visible at the first place when you open it, but if you click on solutions, it tells you how you can do it. So of course you don't cheat, you quickly take that away. First do it yourself, try it, and then you look and check whether it's proper way. And sometimes there can be differences, but you will find out how to work with it and what to take from it once you get to this point. Right, so this is basically how the content is organized. So we have some text, some figures, some tables. We have links to interactive graphs. There's exercises in there, and there's one exercise where you will find it doesn't have a solution to it, so you cannot click on a solution. It's not there, and this is the one that you do as an assignment. So if you're supposed to do an assignment, you click on this exercise, you try to work it out, and you submit it to us. And having submitted the answer, then you are able to proceed to the next session. So that's basically what you're supposed to do. What other things are there? If you look at our main page at the box, you have a button where you can press on quizzes. If you press on quizzes, every session has quizzes with it that you can go through, test yourself various times if you want again. And this is now well established, and from the feedback we can also take that many people found it useful to do it and test themselves on the concepts. And there's one for every session, as I said. Finally, I mentioned webinars before. We used to do webinars, regular webinars on the assignments, but because people are not really synced up, so not doing things simultaneously, it's very hard to keep that up, to have it done in the moment when you actually need it. So we put video recordings or video online tutorials on YouTube, and they are here under the online tutorials tab. You can go there for every session. There's a couple of videos which you can go to, click on them, watch if you want. And they're mostly related to the assignments. So there's all the topics that are required in the assignments are dealt with in the tutorials. So you might find some help if you get stuck there. And before we come to the actual help, let's have a look at what A further section looks like. This was now to do with networks. As I mentioned previously, the coding language here is MATLAB. And as you saw in the beginning, we have actually 3 coding languages that we offer to you. So the second is R, mostly for statistics. So if you want to learn proper statistics, do the statistics module, you will learn to do it in R. And the third one is in Python. Maybe you now ask why different languages is not one enough. Well, no, probably no. Languages are developing quickly. There's new languages coming up again, and you can see that some like MATLAB require a license, so you have to pay to use them, and others like Python are free, and you can just work on them with a community where there's no license involved. So there's a definitive advantage to know about these options and to be able to test all of them. But the main point in learning different languages in the first place is that you have to learn to learn. Right? What we encourage is once you learn one thing, it doesn't mean that this will, once you're out of, say, your PhD or out of your postdoc or whatever your current position is, once you move forward to another position, you might find yourself in an environment that doesn't support your old language, or something new has come up in the meantime, or you work in a field that prefers to work in something that you're not familiar with. So you need to learn, and this we do by offering you towards the final third of the course a different language. So I'll just show you what that looks like. It's a little bit different from the previous ones because it's more modern. So that was just built 1 year ago, and you're now the first cohort to actually work through this in the way that we have set it up, but it's still the same thing. You have the materials set it up, you have concepts that you are introduced here. This is all dealing with bioinformatics, so having a lot to do with nucleotide sequences, protein, amino acid sequences, protein structure, and so on. So, but based on these biological concepts, you then learn programming concepts. And what you will find is that the Python course is more of a proper programming course. So if you have gone through the MATLAB course, we hope you find it easy to do it because it's just getting the job done. But then if you opt for Python, you actually learn proper programming practices and also how to structure your code well, advanced tricks that you might find useful if you continue to do more serious programming, for example, as part of a research or a professional project. So similar here, we have after the introduction of contents, loads of examples that you're supposed to type and to work through in your own programming environment. And then once you have done this, you get exercises, like in this case, can you see that? It's like taken from pathogen and disease relationships. And you get an exercise for which, of course, you are provided with a model answer that you can check whether you have done it right before you do the assignment that you submit to us. So having said this, let's go back to the overview of the session, where you can see in the end you have the assignment, where is what you are supposed to hand in to us, but where is also the way that we want you to work. Namely, and I'll show this, I'll just try to bring this up for you. Give me a short moment. And hopefully that's open now. It's loading in the background. We have provided you with MATLAB live script in this case, and the live script means that it can be a proper lab journal or programming journal where you have text that gives you instructions. You have also links to materials that you might want to use, links to files that you have to download, and so on, all these things. And where you then have boxes where you can enter your code. So you respond to the problem, to the challenge that you're given with coding. And then once you fill in the code, you can then upload this filled in file for us, and we're going to check it and give you some feedback if it's necessary. So this is what it looks like. And it's a very quick method. I think I don't want to give you the answer now, of course, but what we can do is we can, of course, take a look at what this will look like when you work. And this is what I really want to encourage you from day one. This is how this course is best taken advantage of. You have MATLAB open. You don't need to read anything without MATLAB or Python or R open. It's not useful. Right? There's a lot to read, yes, but it's not useful. You have to have your programming environment open. So in this case, it's a MATLAB live script. I've just opened one, and then, well, let's do a very simple thing. Let's go in the live editor. Say I want to have a text. Let's create some data. So if I want to create some data, what do I do? So there needs to be a code. So I create a data set. And what does it look like? So I just create random numbers. We don't have time to do a proper session. And if I do, maybe if I say 10, and that's what you're going to learn then. If you have a code that says run 10, this is the way in MATLAB to say create random data. If you run that code, you press the run button, and then it shows you the data on the right-hand side. Yeah, then you have random numbers, and if you understand the code, it's 100 random numbers that you have generated, namely a 10 by 10 arrangement of randomly picked numbers, none of which is smaller than 0 and none of which is larger than 1. So what do you do with those data? Well, maybe you want to look at them. So we might want to say plot data. And we take another piece of code. How do you plot data? Well, you say plot. That's how you do it in MATLAB, and that's what you're going to do. So you have created something, and then when, for example, visualize it, you just say plot data. It's the easiest that I come up with at the moment. And if you do that, the plot shows up miraculously on the right-hand side of your graph. And if you don't like plot data, you can also show maybe a heat map. So this is then a different way of doing it graphically. And if you say this data that I have created previously, I want to see them as a heat maps, as a heat map. So you can see all the possibility that you have here in MATLAB. Run that code. And in addition to the previous plot, you will also find a heat map on the right-hand side. I don't go into this, you have to do it yourself, and that's what you have to do, right? And once this is finished and successful, if this is the plot that you wanted, you can upload and send back to us. So, and I want to reiterate, this is what you need to do. The reading, yes, the material is there, but what we want you to do is have the environment open, keep plotting, and of course, if you that is now because I have prepared it. If you make an error, like you think data is a plural and it needs a plural S, and you try to run something on data with a plural S, then what will it do? Well, something will go wrong, you will get an error. So the majority of your work will then consist in debugging the errors, understanding what went wrong and what to do. And MATLAB gives you some help. It says data with an S at the end is not known. So what do? Obviously, take that S away and rerun the code, and everything should be fine. And hopefully you get the same heat map now visualized on the right-hand side. So yeah, I think that's what I can say. Coming to help, of course, we know that because it's pure online learning, there can be frustrating moments, and especially if you do it alone, that's something where there can be obstacles and something never works, even though you tried everything and you have read carefully the instructions and you have followed the advice that we have given. Still, if it doesn't work, what can you do? Well, first of all, every session that we have has with it an online forum where you can post questions. So please use them. See what session you are in, go to the forum for that session, post a question, and it will be seen by a couple of people, and hopefully you will get an answer within a fairly short time. We try to be as quick as possible, and apart from, I think, Christmas holiday and summer holiday, we basically do a good job in trying to answer as quickly as possible. That may be asking you further questions, or that may be giving you right away the answer, the solution that you need, or by giving you some hints that might help you to find the answer yourself. So depending on the nature, we'll try one of these cases. What else can we do? Of course, you have emails. If you have emails, you can also try to direct email, though we don't really discourage that. But if you want to do it, or you think is then not visible to others, by all means, try to do that as well. We try to reply to things. If there's something that you absolutely feel frustrated with and you want to give up, then is your alert signal must go, I have to contact somebody. So if you find my phone number, if you call me, that's fine. In the worst case, I will refuse to answer the phone call, but if there's something urgent, we are definitely trying to come back to you and to help it. So that would be from our side. We can also set up sessions like these ones here, where we are over like Skype or Teams, Microsoft Teams we are using now, to set up a session where I can actually get access to your screen, and I will then try to guide you through the solution when I see what you are doing and when I can try to spot what might be, where we might be able to improve it together, so we can work things through together while I see what you are doing. And of course, as you might have guessed, something like online learning can be much more fun if you don't do it alone, if you find somebody who physically sits to you together, not all the time, because coding is lonely, you need to do it yourself most of the time, but through the problems, it's very good to have somebody to talk with somebody. If you find somebody, you're a student, you find a fellow student, you're in a company, you find somebody from that company, or you find somebody who is maybe remotely, like we are in contact now via video conferencing software. And all of this can be done. Find somebody, ask us, ask anybody in your working environment, and try to find somebody who is in a similar position, who wants to go with it through you. All the experience with online courses shows that this is the best guarantee to actually get things done, because you can then mutually ask each other, how have you been doing? Are you back? And from our side, we will try to encourage you if you see that you fall back behind the schedule, but of course you are free to choose your own schedule. It's online and it's you who drives this thing. We only can encourage it and help. So that's, I think, as much as I have to say. Before anything else, I want to summarize that what you need to do now is to go to that page that we had before. You go to, which one was it? Can I get it back? Maybe I can take MATLAB down. Go to this page here, home page of Module 1. Start from the beginning and read through the instructions and make sure your MATLAB is running properly. And once your MATLAB is open, do get started. I want to thank you for joining us today. I hope you have a successful sessions. Don't hesitate to ask if you need anything surrounding this course. And I want to finish with an announcement. We're going to have webinars to which you will get a separate invitation. And the next one will be on 27th of November, a webinar called Algorithms of Life and Disease, where we talk about related things about biological questions that can be improved if, instead of doing it the traditional way, the verbal way, the biological experimental way only, if you add code and algorithmic thinking to it. And we'll start on 27th of November by looking at papers by a guy called Starling, who worked here at UCL, actually in this building with me, and who basically invented endocrinology. And we're going to look at the classical paper from 1905, and then we're going to look at the paper from 2019, where actually this concept comes up and is shown to be of the utmost importance for the understanding of how diseases can come about that have to do with endocrinological dysfunction. The next week after that will be, the next webinar after that will be 11th of December on Hodgkin and Huxley and how neurons fire. So with this announcement, to which you will receive invitation, Geraint Thomas and I would like to say goodbye, wish you all success, and remember to open MATLAB before you do anything else today or in the future. Thanks for joining, and we'll be in touch. Good luck.
Thank you.
Bye.
Bye-bye.